You are welcome to another lesson, logarithms. Before you study logarithms, you would have studied indices. And so if you have not studied indices, you should go back to the video, watch the video on indices, and then come and continue with the logarithm. Logarithm and indices move hand in hand. Your understanding of indices is very necessary for you to understand logarithm. We know if you have a to the power m and the value of this expression is equal to p. What logarithm does is if you don't know the value of m, let's assume 3 to the power x is equal to 27. So if you don't know the value of x, then logarithm wants to help you find the value of x. So that is the relationship. And so if you have an equation, an exponential equation, we will convert it to logarithmic equation and then vice versa. So let's see how we convert from exponential equation to logarithms. Okay, so we take the first one, so logarithm, and then here you have base. Let me use a different color. Here will be base. And then the logarithm value, the value, let's say here, I'll call it the value that you obtain for the exponential equation. And then it gives you the exponent. Okay. And I'm relating these labels to what we have on the exponential equation. So this one, our base here is a. So a is our base. And then the exponent. And then for the expression a to the power m, when you do the evaluation, your value is p. So p is our value. So that is it. So if you are to convert a to the power m to logarithm, this is what you are going to get. So a to the power m is equal to p can be converted to logarithm as log of p to the base a is equal to m. I hope this is understandable. And then the second example, so it's going to be log 27 to the base 3 is equal to x. Now we continue. If you also have a value which is logarithmic equation, how will you also convert it to exponential equation? So assuming you have log x to the base a, and this is equal to f. Then if you are converting this to indices, remember a is our base, f is our exponent, and x is the value. So here we will get it as a to the power f is equal to x. I hope it's very clear to you. I'll take a second example. So log p is equal to 5. Now, if you have, okay, so I'll take it again. The second one, we have log p to the base x is equal to 5. And that will give us p is equal to s exponent 5. I hope this is clear. Okay. In this example, we have to express each of the equations given to logarithm. So I have 3 to the power 4 is equal to 8. So what I'm going to do is I have log, and as we said, the base number is what? 3. And the value is what? 8. So the exponent will be 4. So this is how we express indices in the form of logarithm. Okay, the second example, log 32 and the base is 2. The exponent is 5. The third one, the base is 3. So base 3 here, and the value is 1 out of 27. And then the exponent is negative 3. So this is how we convert indices to logarithm. I hope this is understandable. In the next set of examples, we are to convert from logarithm to indices. So the first example, we have log base 10 and the number is 100, and we expect that the exponent is 2. So we have the base to be 10 and the exponent is 2, and the resultant value is 100. So that is how we also convert logarithm to indices. The second example, we have log 1 over 125, and that is equal to negative 3. The base is 6. So we have base 6 to the power negative 3 is equal to 1 over 125. The third example, I hope you can try this. The base number is what? 27. And the exponent is 1 over 3. And the resultant value is 3. So this is how we also change logarithm to indices. Okay, in this set of examples, we have a variable and we are supposed to find the value of the variable. So for example 1, our base is what? 6. And the value we are dealing with is x. So the exponent is 2, and that gives us x. So 6 squared is 36, and that is x is 36. Then example 2, the number we are dealing with is 1 out of 25, and the base of that number is 5, with y as our exponent. So if you remember how we find exponential equations, then here we can say that 25, 1 over 25 is the same as 1 over 5 to the power 2, and is equal to 5 to the power y. And that's 1 over 5 to the power 2 can be written as 5 to the power negative 2, and this is equal to 5 to the power y. Since there is an equal to sign between them and the bases are the same, it can only mean that the exponents are also the same. So y here is equal to negative 2. Is We continue to look at the laws and properties of logarithms. Now, before we look at the laws and properties of logarithms, let us establish the following conditions. We are going to assume that P is equal to log to the base E of x. And then we will also assume that Q is equal to log to the base E of y. So let's observe that the two equations have the same base. And the fact that they have the same base is going to be very important to our course. Okay. Now I'm going to change each of these equations into indices. So if you remember how we do it, the first one, which is P is equal to log s to the base A, will become x is equal to a to the power p. I hope you remember this. And we will label this as our equation 1. And then the second one, we will have it as y is equal to a to the power q. And that we also label that as our equation 2. Now, as we have already created the conditions, we have equations 1 and 2. What I will do is I will multiply equation 1 by equation 2. So multiply equation 1 by equation 2. If that happens, I'll get xy is equal to a to the power p multiplying a to the power q. Okay, now back to indices. A to the power p multiplying a to the power q. They have the same base. You know what should happen, right? So xy should be equal to a to the power p plus q. I hope you've not forgotten this. Okay, so with this, I'm going to convert it to logarithm. So I'll get it as log. Remember, look at the base. If I am converting this to logarithm, look at the base. So let me put the exponent in brackets. So log xy to the base e is equal to what? The exponent, which is p plus q. So with that, I will obtain let's remember let us remember that p is equal to log x to the base e and q is equal to log y to the base a. So what we are doing next is to substitute them. Okay, so we have log xy to the base a to be equal to log x to the base a plus log y to the base a. And this is our first law of logarithm. Log xy to base a is equal to log x to the base a plus log y to the base a. Now we go ahead and look at the second law. So with the same condition, now I am going to divide. So I'm doing division of the two equations. So equation 1 divided by equation 2. And that I'm going to get x over y is equal to a to the power p divided by a to the power q.
And in indices, when the bases are the same and they are divided, you remember we subtract the exponent of the divisor from the exponent of the dividend. So here we will have x divided by y is equal to a to the power p minus q. Okay, we are going to now change this to logarithm. So we have log, our base is a, and the value is x over y, and the exponent we got is p minus q. Let's remember that p and q represent log s and log y respectively. So now let's do the substitution. Log x divided by y to the base a is equal to log x to the base a minus log y to the base a. And this is our second law of logarithm. And this expression is true for all logarithms of the same base. Okay. Law 3. In this law, I'm going to use p is equal to log x to the base a. Now let's convert this to indices. If we do that, we are going to get x is equal to a to the power p. Let's go ahead and find a common exponent for both sides of the equal to sign. I'm going to use m. So x to the power m is equal to a power p to the power m. So I will simplify that by removing the bracket. Now, from here, let's change it back to logarithm. So we are changing this initial equation to logarithm. Remember, our base is a. So we have log to the base a, and our log value, or that resulting value, which is x to the power m, and then that is equal to the power of the base, or the exponent of the base, which we have now as mp. We shall not forget that p represents log s to the base a, and so let's do the substitution. Log x to the power m base a is equal to m log x to the base a, and this is the third law of logarithm. If you have log of a number, in this case we have the log of a number x to the exponent m, what will happen is the m will drop to multiply the log of that number. So that is the third law of logarithm. Laws have been summarized here. We have the first law: if two values are multiplying, then logarithm, it is true in all cases that when you separate the two values in separate logarithm values, you have the sum of the two logarithm values being equal to the initial product of the values, as we see here. So if you have log xy to a common base a, Then we can write it as log x to the base a plus log y to the base a. Then we also looked at the second law, which is the law of division. So if x and y are divided, log x or x over y to the base a, then we can write it as log x to the base a minus log y to the base a. And then we just looked at the third law where the exponent has to drop. And these are the laws of logarithm. Properties of logarithms. We have looked at the three laws of logarithm. And the next thing we want to look at is the properties of logarithms. So the first one we note is that in indices, x to the power 1 is equal to x. So any number to the power 1 is the number itself. This expression or this equation, let's change it to logarithm. So the base here is x. So that will be log to the base x. And the resultant value is also x. So that means that it's going to be log s to the base x. And that is equal to the exponent of the base, which is 1. This is our first property. If you have log of a number to a base that is equal to the number, the result will be 1. So assuming I have log 5 to the base 5, log of the number which is the same as the base. What we are saying is if we have a situation like that, the result is 1. So if you have log 10 base 10 is equal to 1. Okay, so the second one, we remember that, okay, let me use a different variable. A to the power 0 is equal to what? It's unfortunate I can't hear you, but I trust you said 1. So any number to the power 0 is equal to 1. Now let's change this to logarithm. Our base here is a, so log to the base a. And the exponent is 0, and the resultant value is 1. So it's log 1 to the base a, and that's equal to the exponent, which is 0. This is our second property. So log 1 to any base is 0. Log 1 to any base is 0. So you see, everything we are looking at has a relation with indices. That is why logarithm and indices are like siblings. Okay, so the third thing, what I'll say is that if you see anything log and the base is not stated, then it means it is in base 10. So any log whose base is not stated is base 10. So let's take note of that. If I say log 10, I just say log 10. I don't show the base. It means it's already in base 10, and the answer will be what? That will be 1, because log of a number to the same, to a base which is equal to that number is 1. Okay,